So welcome to the presentation entitled as What Do Practitioners Expect from the Meta Modeling Tools? As you know, the meta modeling tools, there are many meta modeling tools available in the market or the research communities. Those meta modeling tools allows you to just define the meta model and also the modeling language, and using the meta modeling tools you can also just develop some model transformation tools, and the tools, meta modeling tools, gives you the modeling editors through which you just specify models in accordance with the modeling language. I believe that everybody knows all these concepts and they are familiar. I believe you're all familiar with all those concepts. So what is important and interesting is practitioners are involved in all these stages essentially. So practitioners are the one who use the meta modeling tools. They are the one who just develop or use the model transformation tools and modeling editor. They are the one who just specify the models or use the models specified. So we are interested in understanding essentially practitioners' perspectives, expectations, and challenges towards the meta modeling tools, meta models, modeling language, and models. Because as I said, practitioners are essentially involved in all these different processes, or let's say the technologies used on those processes. So before starting my talk, let me firstly just clarify what we mean by practitioners. A practitioner to us is someone who uses or edits models, or uses or edits meta models, or someone who doesn't use edit models or meta models but do feel interested. Practitioners may be they may hold diverse job positions, including software developer, architects, consultants, managers, system engineer, analysts, or maybe high-level managers even. So practitioners may vary depending on their education levels, work industries, and experiences. So the first concerns that we address is practitioners' approach towards modeling and modeling language. I mean, there are essentially many different research questions to be investigated, including practitioners' understanding towards modeling, practitioners' expectations from modeling, practitioners' challenges, and their perspectives towards different modeling techniques, including software architecture, design pattern, and so on and so forth. And practitioners' perspective towards different types of modeling language or applying models at particular domains, such as embedded domain. So the good thing is the literature already includes several empirical research and their results. So if you just Google, you will come up with many survey papers which discuss the results based on those research questions. Okay, so I've just listed here some of the surveys that you can easily find out in the literature. Okay, so essentially I've just indicated here 21 of them. Okay, there is many more. Okay, so another concern is practitioners' approach towards meta modeling. In meta modeling, the questions are similar essentially. Practitioners' understanding towards meta modeling, their expectations from meta modeling, their challenges in meta modeling, and their perspectives towards different tools, different meta modeling tools, and towards applying meta models at particular domains, such as embedded domain. However, the literature does not really consider answering those research questions, that there is indeed a lack of survey studies on practitioners and meta modeling. The current work essentially focuses more on analyzing the existing meta modeling tools for some requirements and proposing kind of taxonomy of requirements for meta modeling tools, but there is essentially a lack of practitioner surveys on meta modeling. So our goal is essentially to focus on three important research questions. We want to investigate three important research questions. What are the usage frequencies of the existing meta modeling tools in different problem domains? What do practitioners in industry expect from meta modeling tools? And what are the challenges that practitioners face with on their meta modeling activities? So to be able to reach our goal, we just design and execute a survey, a practitioner survey. Okay, so in our survey, one of the, before designing our survey, one of the first questions that we try to answer is which meta modeling tool requirements that we need to focus on our survey. I mean, to be able to determine the meta modeling tool requirements that we will focus on the survey, we just utilize from an article published by Aldrich et al. In 2013, whose title is The State of the Art in Language Workbenches. So Aldrich et al. In their article just come up with a feature model proposed out of the language workbench workshops. They just organize language workbench challenges in between 2011 and 2013, and in those challenges, they just obtain some feedback from the participants, and using those feedbacks, they come up with a feature model that indicates the requirements of the meta modeling tools. So they just categorize the requirements into language definition, editors, language validation, language testing, and language composability. In language definition, they focus on notation semantics. In editors, they focus on the editing mode, syntactic service, semantic service, and so on and so forth. I'm going to get into further details about those requirements, so I'm not going to explain the concepts listed here. I'm going to do so in a while. Don't worry about that. So we prepared 25 different questions. 5 of them is the profile questions. 1 of them is a question for understanding the tool usage frequency. And we have a set of questions for each category of requirements that I've just shown to you. Okay, the questions are multiple choice. Most of the questions are multiple choice. And also there's a free text option to let you participants type their own answers, which are not listed in the pre-given answer list. So having designed the questions, we just conduct a pilot study with a small set of academics and practitioners, and we resolved many issues listed here. Okay, we just added also new requirements, for instance, such as model transformation and code generation. Having done so, we executed our survey. We executed the survey online via Google Forms, and the survey has been accessible in between June 2020 and August 2020. To spread the survey, we just use our personal contacts. We just use many different mailing lists. We just try to access practitioners who contributed to papers. We also use several groups in LinkedIn, which are about modeling and meta modeling. And in total, we sent email or accessed 300 different individuals, and we got 103 different participants from diverse countries and industries. So let's now have a look at the results of our survey. So first, let me just give you the results of the profile question. So we have participants from 24 different countries. Okay. So also there are many job positions. However, as you see, the top job position is software architect, which is followed by the software developer and programmer. And if you just check the work industries, we got the highest response from the defense, military, and aviation industry, which is followed by research and IT and telecommunications. If you just have a look at the domain for which the participants viewed DSMLs, so embedded is the top domain, which is followed by automotive, okay? And participants, as you see here, participants comes from varying degree of experiences. There are participants with 10 or more years of experience, while there are participants with less than 2 years of experience. But as you see, the most of the participants have either 10 or more years experience or 2 to 5 years experience. So the participants with 6 to 10 years experience quite less. So if we go further, so let's have a look at the meta modeling tool usage by the participants. So Sirius comes at the top. So as you see, most practitioners use either of the 5 different meta modeling tools: Sirius, GEMS, MetaEdit Plus, Xtext, and Microsoft DSL tools. Among the top 5 meta modeling tools, Sirius and Xtext and GEMS are Eclipse-based tools. Okay, they are based on Eclipse modeling framework. Here, Xtext is the only meta modeling tool that offers a textual visualizations. Quite interesting. And some of the tools are rarely used. Okay, so anti-LR, concept-based, Melange, Gmok, Graffiti, WebGME, Cameo, and so on and so forth. So if we go further, some meta modeling tools used for a few particular domains. Okay, so if you just check, those meta modeling tools are just used in few particular domains, while some of the tools are essentially used in various domains. For instance, MPS is not one of the highest, one of the frequently used tools. However, it is essentially employed in various domains. If you just check here, so in almost all domains, the top used meta modeling tools is the MetaEdit Plus, except the embedded domain, where the top used meta modeling tools is GEMS. So the tools that are used in the greatest number of countries are GEMS, MetaEdit Plus, Sirius, and Xtext. Okay, so some of the meta modeling tools are each used in 1 or 2 countries only. Some countries, on the other hand, use particular meta modeling tools more than the other tools. For instance, in USA, as you might expect, Microsoft DSL tools are the top used tools. In Finland, as you might expect, MetaEdit Plus is the top used tools, and many European countries, top used tools are Eclipse-based tools. In Netherlands and Turkey, the top used tools is GEMS. Okay, so many countries also include some practitioners who prefer to use their own solutions. They actually prefer to use their own modeling or meta modeling solutions. Okay, there are essentially a considerable number of practitioners. So let's now focus on the results about language definition. So in the language definition, we focus on the types of the notation sets. There can be essentially different types of notation sets. So diagrammatic visualization is the top preferred notation sets for the practitioners. So in diagrammatic visualization, we mean just the model elements to be specified using graphical symbols. Textual visualization comes after that, which enables the model elements to be specified in terms of text. So most of the practitioners prefer diagrammatic and textual visualization, as you see. Other types, such as tabular visualization or matrix or map and hybrid, are not that much used by the participants, by the practitioners involved. So regarding the semantics, we consider interpretative semantics and translational semantics. In interpretative semantics, interpretative semantics just promotes the model execution without performing any translations into some intermediate formats, while translational language semantics promotes the definition of model translation into some intermediate format that can be executed. We consider translational semantics in terms of model-to-text translation, which is to do with defining the semantics in terms of the translation into some structured text notation, such as source code. And there's also model-to-model translation, which is to do with just defining the translation rules in terms of in terms of the translation to another model with a different notation set, such as producing entity relationship model from a UML class diagram. So if you check the diagram here, translational semantics is much more popular among practitioners than the interpretative semantics. Okay, so as you see, 37% of the practitioners prefer translational semantics, both the model-to-model and model-to-text. On the other hand, it is just 15% of the participants who exclusively prefer interpretative semantics for defining their language. Okay, so if we just have a look at the challenge, I here just summarize the challenge in an abstract way to not lose time. So the top challenges are indicated by the practitioners are meta modeling tools, steep learning curve for defining the language syntax and semantics. And there's also lack of support for training, including tutorials, guidance, and so on and so forth. And a few of the participants just concerned about the lack of support for integration with version management tools for versioning the meta models definitions, the collaborative meta modeling, keeping the language syntax and semantics complete and consistent as the new modeling elements are introduced. So let's now have a look at results about the editor services. In editor services, let's start with the editing mode. So here we consider two types of editing modes. One is free-form editing. Here the users just edit a textual or graphical model that is stored persistently. A persistent model here is transformed into some abstract representation, which is then transformed into executable representation. In projectional editing, users actually edit the projections of the model's abstract representation, which is stored persistently and transformed into executable representation. So each projection might be in different formats, such as graphical, textual, tabular, matrix. And unlike the free-form editing, the projections here, edited by the user, are not stored persistently. According to the results, practitioners are not familiar with projectional editing. Most of the practitioners just prefer free-form editing, as you see. Let's have a look at some other syntactic editor services that practitioners prefer to use. As you see, model reuse, which is to do with just keeping the models in a repository or just creating new models by reusing the existing models in a repository, is a top popular requirement for many participants. As you see, 75% of the participants interested in model reuse. Also, model comparison which is to do with detecting and reviewing the differences between different models and even merging them, is also quite popular, which is followed by syntactic completion templates. So syntactic completion template is to do with just providing some incomplete models to the users that can be easily just edited and completed to reach a maybe domain-specific model. So it's also quite popular. So these are the top popular editor services requirements by practitioners. The rest of them are not that popular, okay? So if we have a look at the semantic editor services, error marker is a top popular semantic editor services, which is to do with highlighting model elements and any associated error messages for detecting the semantical errors, okay, such as the violation of the well-formed rules. So most of the participants are interested in error markers for the semantic editor services. This is followed by automatic update of the models when meta model changes, okay, so which enables the models to detect modelers to detect any errors due to the semantical change automatically. Semantic completion, refactoring of models comes after. They are also quite popular. So among the other editor services, most of the practitioners are interested in document generation from models automatically. They're also interested in importing, exporting models for sharing the models among collaborators. Okay, version control system integration is also popular. It goes like that. I need to be quite quick. If you just have a look at the challenge, the top concern is the usability of the editors. Indeed, a considerable number of participants just indicates the usability issues, especially about Eclipse, Xtext, Extend, MPS, meta modeling tools for developing editors, but they didn't give enough details to us. And also one of the participants just indicates Xtext lack of support for scalability and traceability based on OSLC linking, which is an open service standard. Also, some participants are concerned about the editor's lack of support for model versioning, training, and integrating editors with other development technologies, such as .NET, to combine modeling and coding. One of the participants indicates the lack of support for web-based editors and syntax coloring. So, if you just have a look at the results about model transformation and code generation. So the top requirement preferred by the participants is the error detection. Most of the participants wants to detect errors during the code generated development, which is followed by syntax highlighting. So syntax highlighting is to do with coloring the code for transformation, which facilitates the readability and detection of the syntax errors. Scalability is also important, which is to do with developing large transformation tools with hundreds of lines of code for transforming large and complex models. So these three are essentially more preferred by the rest of the given the requirements for the model transformation and code generation features. And regarding the challenge, just a few participants indicated some challenges here, which are to do with adapting the code generators with end-user requirements, training support, integrating code generated with external Java programs. And one of the participants just indicates that the existing transformation technologies are too Java-centric and neglect the needs of the embedded domains. If you have a look at the language validation is concerned with meta-modeling tools support for defining the language validation rules that can be executed via the modeling editors to validate the models. So we consider two types of validations here, structural and semantic validation. So structural validation is to do with the structural aspect of the language definitions, such as the multiplicities of the language elements and containment relationships. Semantic validation is to do with the semantical aspects, such as the name and type analysis. Most of the practitioners are interested in both of them. Okay, 75% are interested in defining the validation rules, both structural and semantical aspects of the language development. So if you go further, some participants, indeed, 72% of them indicates that they just desire the integration with some external validation tools, such as formal verification tools, theorem provers, simulation tools, testing tools. And indeed, a considerable number of them wish some automated model and meta-model validations for the user-defined properties, user-defined and predefined properties and rules. Okay, so just a few participants indicated challenges here about the language validation, which had to do with checking any model for the validation rules at modeling time, defining complex validation rules. The ability to define complex validation rules are the challenge they indicated. So if you just have a look at language testing is concerned with testing different aspects of the language development, such as syntax semantics, editor services, code generator, and validation rules. So syntax semantics testing is for checking the language meta model consisting of the expected modeling elements and relationships, or the syntax semantics rules have been defined correctly or not, or completely or not. As you see, semantic testing is the top preferred testing desired by the participants. They really want to test their semantics definition to understand whether they define the semantics correctly, meeting some requirements. And validation testing, which is to do with testing whether the validation rules are defined in accordance with the language requirements and successfully used for validating models correctly. So it's also popular among participants, okay, which is followed by the code generation testing. Here, the goal is essentially to test whether the transformation tool performs the transformation correctly in a way that meets the quality expectations. It's also quite popular. It goes like that. Again, just a few participants indicate some challenges here, which are to do with specifying and executing test cases on different aspects of language, integrating any external testing tools, or the model-based testing of different aspects. So the last part is about language composability. Language composability is to do with the meta-modeling tool support for extending an existing language with some new features or unifying the parts of multiple languages for developing a new language. So we consider here composability in terms of different aspects of the language. As you see, composing semantics of a language is the top preferred requirement for the participants. Okay, so this is essential to do with reusing the semantical definitions of the existing language, such as UML, and this is followed by the compositional development of the code generation or model transformation. So, for instance, reusing transformation templates, patterns, and existing code, and syntax validation and editor compositions comes just right after these two requirements. So just 3 parts were indicated and challenged here, which had to do with composing different languages without changing them at all. Difficulties in performing composition with textual language they indicated, but they did not give any further details. So regarding the lessons learned, I don't know whether I have time to just discuss the lessons learned. If I do not have time, I could skip here.
Well, we have just one question, so you have time.
Okay, so I have just time for the question. So shall I skip the rest of the?
Well, there's only one question, so probably you have time to.
Okay. So
go deeper.
Yeah, sure. So I have 3 or 4 minutes left anyway. So lessons learned. So while most practitioners prefer either diagrammatical or textual visualizations, hybrid visualization is neglected. Practitioners are not familiar with hybrid visualization as far as we see. This might be due to the fact that most meta-modeling tools ignore hybrid visualization. Practitioners define the language semantics by means of translations into text or model. Most practitioners ignore interpretative semantics definitions. Collaborative meta-modeling is really important for many of the practitioners. They really wish to export the language definitions or version the definitions in a repository for later reuse. Practitioners are not familiar with projectional editing. Indeed, hybrid modeling that could be possible with projectional editing is not preferred either. And also MPS, meta-modeling tool that supports the projectional editing, is rarely used. Reusing models, meta-models are the top concerns of practitioners. Defining the language syntax and semantics by reusing the definitions of the existing language, reusing the existing models by extending or modifying them is really the top concerns of many practitioners. And versioning models, meta-models is also highly important. Practitioners really wish to integrate some version control systems to be able to compare and merge models and meta-models or different versions of them. Defining the validation rule is also important for most practitioners. They are really interested in validating both the structural and semantic aspects of their language. And practitioners also wish the meta-modeling tools to be integrated with external verification tools, such as formal verification tools, simulation tools. Testing the language semantics is the most desired testing facility. So likewise, the compositional definitions of the semantics is also most desired composition facility for many practitioners. So thanks for listening. The results have been published in an article. So here I just give the picture of the article. So if you want, you can just read the detailed results from the article. Thank you for listening.
We have one question, which actually is maybe more a remark. What is a textual visualization? Maybe it's a contradiction. And there is a discussion on the chat where people guess representation is a better wording.
So textual visualization is to do with just enabling the model elements to be specified in terms of text, such as writing code in programming language. So that's what we consider as the textual visualization. For instance, Xtext provides a textual visualization.
I have one question. Well, I noticed there's only one person looking for support for web-based editor. So yeah. I really hope definitely there is not only one person in the world looking for that.
Actually, this is one of the challenges. This is one of the lessons that we learned. I mean, the thing is, the challenge questions in the survey are essentially free text questions. Since they are free text questions, I mean, practitioners essentially just try to avoid themselves from writing challenge. So it is, I mean, actually, one of the lessons we learned is we should have just made them some list of answers and also let them to choose their own answers. Because if you just give them the free text option, many practitioners just omit writing any challenge. So they just write one of them only writes the support for web-based editors. Yeah.
The migration of models following an evolution of the meta model is an important topic also. Has it been identified in your survey?
Essentially, yes. Migration of models. Yes, that's true. This is one of the points that are not explicitly indicated in the survey. Also, this is one of the lessons that we learned, let's say. Essentially, we just here indicate some questions about editor services that include some options about importing or exporting models, but there is no any migration support. There is no any direct option about migration. Yes, that's correct. It's one of the lessons that we learned after we design and execute the survey. Yeah.